Okay, so this is the first problem from the book, and we're going to get started with part A. So this is just adding the two vectors, which means we have to add each of the separate components. So let's say the sum of the two vectors is C, and it has components Cx, Cy, and Cz. So Cx is the sum of Ax and Bx. So that would just be 2 plus 5 equals 7. And a similar process for Cy. We get -3 plus 1, -2. And then for Cz, we have -7 plus 2, which will give us 9. So our final vector is then just 7i hat minus 2j hat plus 9k hat. For part B, it's the same thing, except we subtract b of x, and in this case we subtract b of y, and here we subtract b of z. So yeah, we're just going to do c of x. We're going to pretend we have the same base vector, but this time it would equal a minus b. So c of x is equal to ax minus bx equals 2 minus 5 equals -3. Cy is -3 minus 1, because this has a coefficient of 1. So we get -4. And Cz is 7 minus 2, which gives us a coefficient of 5. So now our final C vector would be -3i hat minus 4j hat plus 5k hat. Okay, and part C is to find the dot product. The dot product of two vectors is just their x components multiplied together plus y components multiplied together plus z components multiplied together. And so we can just sub in our values since we know all of these values. Ax is 2, bx is 5, ay is -3, by is 1, and az is 7, bz is 2. So we get a dot b is equal to 21. And now it's time for D. So I'm going to erase a bit of A just so we have more space to do D, since D might take a bit more space than the other ones did. Just going to erase up here, and perfect. So I don't memorize the cross product formula because you can just easily find it on the spot. You just first write your different base vectors, i hat, j hat, and k hat, and then you start with the first vector that appears. Here it's a. So we're going to write down the components of a, 2, -3, and 7, and then just under we're going to write the components of b, 5, 1, and 2. We're going to write them again just to the right and the left. And for each of these vectors, we are going to, the coefficient is going to be the product of this diagonal, subtracted by the product of this diagonal. So for I hat, let me just write it over here. C of x, we're going to have the same vector, right? The vector C is equal to cxi hat plus cyj hat plus czk hat. So cx, which is the coefficient for I hat, is equal to -3 times 2. And then we're going to subtract this part right over here. So we're going to subtract 7 times 1. And then for our j hat part, we multiply 7 and 5. We subtract 2 times 2. So yeah, I'm just going to call this vector C, and we can add all of our components right over here. So we have 7 times 5 minus 2 times 2. And k hat is just 2 times 1, as we can see over here, subtracted by 5 times negative 3. So 2 times 1 minus negative 3 times 5. And then we're going to rewrite this all the way up here. And our final vector to represent the cross product is just going to be equal to negative 13i hat plus 31j hat plus 17k hat.